In today's class, we'll learn about problems on unit step function or Heaviside function. Problem number 1 is express f of t is equal to t where t greater than 0 but less than 4, and another function of f of t is phi where t is greater than 4 in terms of unit step function and its Laplace transform. Second problem is express f of t is equal to sine 2t where t is greater than 0 less than pi, and another function 0 where t is greater than pi in terms of unit step function and its Laplace transform. Similarly, third problem is express f of t is equal to 1 for t greater than 0 less than or equal to 1, for function t greater than 1 less than or equal to 2, and for the third function t square for t greater than 2 in terms of unit step function and its Laplace transform. So these examples or these all three problems will solve using one of the important results which one we have seen in the previous lecture. So what is that result? We'll see now. Important result. Result number 1, f of t is equal to f1 of t where t is less than or equal to a, and f2 of t where t is strictly greater than a. Then f of t is equal to f1 of t plus f2 of t minus f1 of t into u of t minus a, and second result is f of t is equal to f1 of t where t is less than or equal to a, f2 of t where t is greater than a but less than or equal to b, and f3 of t where t is strictly greater than b. Then f of t is equal to f1 of t plus f2 of t minus f1 of t into u of t minus a plus f3 of t minus f2 of t into u of t minus b. So these are the two important results which we'll use in our today's class. So first two examples will use result number 1, and for the third example we'll use result number 2. So let's see the problems using these important results now. Hello students. The problem is express f of t equal to t where t is greater than 0 and less than 4, and f of t is phi where t is greater than 4 in terms of unit step function and its Laplace transform. So as we know that, so this is a discontinuous function. For this kind of example is nothing but type 2 kind of example. Already I have given the steps for this. So given question, I will take it out. That is f of t is given, already it is given as what here, t for t greater than 0 and less than 5, and phi where t greater than 4. So we know that f of t is equal to for f1 of t where t is greater than or equal to a, and f2 of t where t is strictly greater than a. So for this we have taken f of t as f1 of t plus bracket of f2 of t minus f1 of t into u of t minus a. So we need to apply this formula so that our given f of t will become, that is f of t is equal to, so f1 belongs to t, that is t plus phi minus f2 is phi, so phi f2 minus f1, that is phi minus t, phi minus t of u of t minus, this is 4 here, so t minus a value is 4. So we need to simplify this. So first term is simple, but second term is what here, unit step function. We need to apply the unit step function. Now for this this f of t, we need to apply Laplace transform. So therefore, so Laplace transform of f of t is equal to Laplace transform of t plus Laplace transform of phi minus t into u of t minus 4. So for this we'll simplify now. I will give equation number 1 for this. So from this one by one we'll solve. So here Laplace transform of t result is 1 factorial divided by s raised to 1 plus 1, that is 1 divided by s square. So this is a first term result. Similarly, for the second term result, that is Laplace transform of phi minus t into u of t minus 4. So for to solve this one, we need to apply unit step function type 1. So here the first bracket, that is phi minus t, is nothing but f of t minus 4 will take consider as what here, f of t minus 4 is nothing but phi minus t. So therefore replace t by t plus 4, t by t plus 4, opposite of this. So therefore our given f of t will become, means here if you replace t by t plus 4, plus 4 minus 4 cancels, we got what here, f of t. So right hand side also we need to replace the value of t, that is phi minus, so because of minus put a bracket, so t value is what here, t plus 4 we are replacing. So replace it and simplify now, which is nothing but phi minus t minus plus minus 4, which is nothing but what here, 5 minus 4 is 1 minus t. So therefore our f of t will become, so f of t is equal to 1 minus t. F of t will become 1 minus t. So we need to apply Laplace transform for this. So Laplace transform of f of t is equal to Laplace transform of 1 minus t. So Laplace transform of f of t is nothing but what here, f dash of s, and Laplace transform of 1 is 1 upon s, minus Laplace transform of t will become how much here, it will be 1 factorial is 1 divided by s raised to 1 plus 1, that is it will become s square. So therefore by unit step function property 2 says what here, it says Laplace transform of t minus a into u of t minus a is given by e raised to minus as into f dash of s. This is by property 2. This is by what here? Property 2. So therefore Laplace transform of a value is 4, so t minus 4 into u of t minus 4 is equal to e raised to minus 4s into f dash of s, or t minus 4 is already, we have taken it as what here, it is 5 minus t into u of t minus 4 is equal to e raised to minus 4s f dash of s. We got here, this is our f dash of s. You write it as it is, which is nothing but 1 upon s minus 1 upon s square. So this we got the result. So this result and Laplace transform of t, which one already we have taken, both together will replace in equation number 1. So therefore equation 1 becomes what here? Laplace transform of, so Laplace transform of f of t will become, so 1 by s square plus e raised to minus 4s into 1 by s minus 1 by s square, or else you can go one more step, or you stop it here only, no problem. So 1 upon s square plus, open the bracket, it will become e raised to 4s upon s minus e raised to minus 4s upon s square, or I can rewrite it as e raised to 4s upon s, middle term first, then here for the first and the third term you can take it as a plus sign 1 by s square common, so we'll get it as what here, 1 minus e raised to minus 4s. So in this way we need to simplify the problems based on this kind of examples. So next example is, express f of t is equal to sine 2t for t greater than 0 less than pi, and f of t is 0 where t greater than pi, in terms of unit step function and its Laplace transform. Solution. So f of t is equal to, it is given as sine of 2t where t greater than 0 less than pi, and 0 for t greater than pi. So as we know the formula, so this is f1 of t and f2 of t, so I'll write directly. So f of t is nothing but, they have given f1 of t plus f2 of t minus f1 of t into u of t minus a. So here f1 of t is sine 2t, f2 of t is what here, 0. So and value of a is pi. So therefore the given question will become f of t is equal to, f1 of t is sine of 2t plus f2 of 2t is 0 minus f1 of t is sine 2t into u of t minus pi. So therefore on simplification f of t will become sine 2t, so on simply plus into minus is minus sine of 2t into u of t minus pi. So we got the f of t now. So we need to simplify this, and I will give equation number
f of t. So first we'll apply Laplace transform. So Laplace transform for both sides. So Laplace of f of t is equal to sin 2t, Laplace of sin 2t minus Laplace of sin of 2t into u of t minus pi. I will give equation number 1 for this. So we have two Laplaces here. We'll find separately and we'll apply later in the equation number 1. Now first term, Laplace transform of sin 2t is nothing but, so Laplace transform of sin 2t we need to apply. So this is a standard property. So Laplace transform of sin 2t is nothing but 2 divided by s square plus 2 square, which is nothing but 2 divided by s square plus 4. So we got the first term result, that is 2 divided by s square plus 4. Now we need to simplify for the second term, that is Laplace transform of sin 2t into u of t minus pi using unit step function. So therefore, and Laplace transform of sin 2t into u of t minus pi. So as per the unit step function, sin 2t we need to consider as f of t minus pi value, that is f of t minus pi value is nothing but sine of 2t. So I need here f of t, so therefore we need to replace t by t plus pi. So t minus pi is there, we need to replace t plus pi. So therefore f of, so if you replace t by t plus pi minus pi cancels, we are going to left here f of t. So f of t is equal to sine of 2 times t plus pi. Now once we got this, we need to simplify this one as, so f of t is equal to, so sine of 2t plus 2 pi. So on simplification, so it will be 2t is nothing but 360, so 360 plus angle is nothing but, so it will become first quadrant, so it will become sine of 2t. So our f of t will be what here, sine of 2t. So we need to find Laplace transform for this. So Laplace transform of f of t is equal to Laplace transform of what here, sine of 2t. So therefore, so Laplace transform of sine 2t is nothing but, it is 2 divided by s square plus 2 square is 4. So this is our f dash of s. So this we are solving under unit step function. So we know that Laplace transform of t minus a into u of t minus a is nothing but f dash of s into e raised to minus as. Actually it's supposed to be e raised to minus as into f dash of s, so which is nothing but, so value of a is what here, t minus pi into u of t minus pi is equal to e raised to minus pi s into f dash of s. So therefore Laplace transform of t minus pi is nothing but how much here, it will be sine of 2t into u of t minus pi is nothing but e raised to minus pi s. So f dash of s is how much here, 2 upon s square plus 4. So we got the second term result. So therefore equation 1 becomes, equation 1 becomes Laplace transform of f of t, equation 1. So term 1 result is 2 upon s square plus 4 and term 2 result is e raised to minus pi s into 2 upon s square plus 4. So we can take this one LCM as s square plus 4, and in the numerator you take 2 common, so it will be 1 plus e raised to minus pi s. So this is the result of the given expression. Hence the result here. So the next problem is express f of t is equal to 1 where t greater than 0 less than 1. F of t is t where t greater than 1 but less than or equal to 2, and t square, so this is less than or equal to 1, and t square where t is greater than 2 in terms of unit step function, and we'll need to find its Laplace transform. So as we know that the given question is, so f of t is equal to, it is 1 for t greater than 0 and less than or equal to 1, for t where t greater than 1 and less than or equal to 2, and t square where t is greater than 2. So as we know that this is f1, f2, f3. So based on this we need to apply the formula as, so here it will be f of t as per the standard formula. We know that it is f1 of t, f2 of t and f3 of t. So where as per this the conditions are here, for f1 of t, t is less than or equal to a, f2 of t, t is greater than a less than b, and for f3 it will be t greater than b. So therefore we can prepare this f of t as f1 of t plus here what happens, bracket f2 of t minus f1 of t into u of t minus a plus, next step we need to write, I will write it down here, plus next is f3 of t minus f2 of t into u of t minus b. We need to remember this. So now as per the given question, f1 is 1, f2 is t and f3 is t square. A value is 1 and b value is 2. So therefore our required result will become, so therefore as per the given question, so f of t will become f1 is 1 plus bracket f2 is t, so t minus 1 into u of t minus a value is 1, plus next one is f2 minus f3 minus f2, so f3 is t square minus t into u of t minus b value is 2. So we got this f of t now by using the formula. So we need to apply Laplace transform for this. So we have almost 3 terms. So first you apply Laplace transform. So Laplace transform of 1 plus Laplace transform of t minus 1 into u of t minus 1 plus Laplace transform of t square minus t into u of t minus 2. So give equation number 1 for this. So therefore, so we'll go one by one. So Laplace transform of 1 is, it is 1 by s. Second term. So second term will be Laplace transform of t minus 1 into u of t minus 1. So here, so this is the function of f of t minus 1 is equal to t minus 1, where we need to simplify this. So replace, you can go directly also now. So replace t by t plus 1. So if you replace t by t plus 1, you will get here f of t. So it will become f of t is equal to, so t plus 1 minus 1, which is nothing but plus 1 minus 1 cancels, t we got. So therefore Laplace transform of f of t is equal to Laplace transform of t, which is nothing but Laplace transform of t is nothing but 1 factorial divided by s raised to 1 plus 1, that is 1 upon s square. So we got this result. So therefore, so this is nothing but f dash of s. So f dash of s we got 1 upon s square. So as per the property, I am writing directly. So Laplace transform of t minus 1, the given question, t minus 1 into u of t minus 1 is equal to e raised to minus as. A value is 1. So minus 1 into s into f dash of s. F dash of s is how much here? 1 upon s square. So we got the second term result now. Now we need to work out for the third term. So third term is what here? Laplace transform of t square minus t into u of t minus 2. So Laplace transform of t square minus t into u of t minus 2. So therefore, so here also we need to consider, so here our f of t minus 2 is nothing but t square minus t. So replace t by t plus 2, so that we'll get it. So we get f of t is equal to, so t will be replaced by, so as per the instruction what we have taken here, so t will be replaced by t plus 2. So this will become plus 2 minus 2 cancel, f of t. So t square minus t, it will become what here? T so t square will become what here? T plus 2 square minus t will become what here? T plus 2. So on simplification for this, so simplify, so apply a plus b whole square formula. So it will become t square plus 4, 2 2s are 4t minus open the bracket minus t minus 2. So therefore t square, so 4t minus t will become plus 3t. So 4 minus 2 is minus 2, plus 2. So therefore our f of t will be what here? T square plus 3t plus 2. So take apply uh, Laplace transform for this. So Laplace transform of f of t is nothing but Laplace transform of t square plus 3 is a constant, Laplace transform of t plus Laplace transform of 2. So therefore, so this is f dash of s. So here, so Laplace transform 2 square t square is nothing but 2 factorial divided by s raised to 2 plus 1. 3 is a constant. Laplace transform of t is nothing but 1 factorial divided by 1 s raised to 1 plus 1 plus Laplace transform of 2 is nothing but 2 upon s. So on simplification, f dash of s will become, so 2 factorial is nothing but 2 itself. So s raised to 3 plus 3 divided by s square plus 2 upon s. So we got this result. So therefore Laplace transform of t square minus t into u of t minus 2 is nothing but a value is 2, so e raised to minus 2s into 2 upon s cube plus 3 upon s square plus 2 upon s. So this result will apply in equation number 1. So equation 1 becomes, Laplace transform of f of t is equal to first term result, which is nothing but 1 upon s, second term result, which is nothing but e raised to minus s divided by s square, second term result, plus third term result is e raised to minus 2s into 2 upon s cube plus 3 upon s square plus 2 upon s. So this is the result. So this is the required solution of the given function f of t. So we have got the expression for unit step function and we got the Laplace transform of this. So in this way we need to simplify the examples of the given function f of t in various types.